Wow, I can't believe that we're already at the final talk of today. We hope that you enjoyed all of these amazing talks. I really have. It's been a really great day. But last but not least, I'd like to present Dmitry Mezhensky, head of big data and machine learning practices at Grid Dynamics, where he leads discipline development, driving R&D and corporate accelerator development. His primary focus is big data consulting practices that help clients become successful big data and ML ops adopters and deliver innovative solutions. In this session, Dmitry will talk about automating manual detection of anomalies by building a data platform and providing a data science teams with the right tools and data to create machine learning models. Welcome, Dmitry. Over to you.
Hello, everybody. My name is Dmitry Mezhensky, and I'm leading big data practice at Grid Dynamics. Today, I'll be talking about digital transformation of modern manufacturing and our experience, how we helped our customers to transform and build their solutions in the cloud. And the agenda for today will be to talk a little bit about current state, what currently typically manufacturing is using on-premise or in hybrid installations. What is our recommendation for reference and data platform in the cloud? The way how we recommend our clients to build it. And then we'll talk a little bit about IT and data platforms and our experience and concrete examples of those. And finally, we'll talk about ML platforms. We'll talk about how these ML platforms should be built, what capabilities are required, and what business use cases can be run on top of ML platforms. So that this will be for today. And starting our journey with the understanding about legacy architectures, they may look like on the slide on my screen. So typically, it may be private cloud with a sliced architecture, which contains processing engine, capabilities like orchestration, running data pipelines, integrating particular ML tooling on top. It may also leverage partially cloud capabilities. Like, for example, we have seen many cases when on-premise architecture, on-premise data platform is leveraging cloud ML capabilities to create and run models. So this is typical platform, and this is typical to our clients who we help to migrate to the cloud. And this is our starting point where we help our customers to start their cloud journey and start building their modern platforms which can onboard business use cases, various technical capabilities, and integrate with ML platforms, with commercial actual ML platforms, like, for example, Dataiku. And typically this journey starts with the understanding what are primary capabilities that should be onboarded on top of the platform. Helping to have these capabilities in mind helps to design a platform which will address all business needs. And typically, we recommend our customers to build sliced platforms in the cloud, which will leverage cloud capabilities and will provide particular offering to various platform consumers, whether it will be data engineering, which will be ingesting data from various data sources, ingesting both streaming and batch data, storing and processing it. In any case, we recommend, and nevertheless, what technology stack you are using, we recommend to introduce data quality of your applications, and we recommend to introduce data governance. These are key points that help to build consistent data, consistent storage, consistent data pipelines, and identify any issues with the quality as soon they appear in the data. On top of a particular data platform, we recommend to build ML platform which will leverage data platform capabilities. That means that ML platform will use all the data sets, ability to orchestrate pipelines, ability to store features if needed, if ML platform is not leveraging its own feature store, and ability to contribute back feature extractions, a part of ML model development. There is a particular data pipeline that should be onboarded to the data platform. It will be much easier. Obviously, not only ML platform and data platform will be built in the cloud, and this is just technical part of the platform, but also to leverage business to use the data to discover any insights from the data and be able to query the data, build reporting on top of it. Platform should provide particular self-service capabilities. Self-service means that platform provides access to the data, ability to query it in SQL-like format. Ideally, it may be a data warehouse which provides SQL capabilities, and ability to integrate with existing reporting dashboards and any kind of analytics on top of it. So this is modern reference data platform and ML platform architecture. And later we'll be talking about particular implementations of this reference platform for both clouds. And our journey will start with IoT and data platforms, and we'll talk about business capabilities that that these platforms can bring to the client, and then we'll talk about particular architecture that may be behind it. So typically, IoT and data platforms provide capabilities such as ingesting structured and unstructured data, building predictive analytics on top of it, predictive any kind of automated anomaly detection, and provide advanced insights on top of the data. So these are major capabilities that data platforms bring to the business. And there are a lot of derived capabilities like data visibility, better understandability of the business, and so on. IoT and data platforms typically are integrated to the already existing environment. It may be a part of on-premise system which sends signals, let it be manufacturing floors, or it may be a case of any other complex system. So that IoT platform should fit into the architecture naturally, be able to process the data, provide particular capabilities like technical capabilities like storage, compute, orchestration of data, orchestration of data pipelines, any kind of automated quality checks on top of it. And finally, on top of this, business capabilities like anomaly detection, advanced reporting and analytic, and so on. While you're building these particular IoT and data platforms, you should consider industry standard features that should be a part of the platform. We recommend to build such platforms in a way infrastructure as a code, with ability to integrate with complex environment, as I have already mentioned. It may be either data lake centric or data mesh platform. That means that it may be a single data lake in your organization, or it may be fragmented data lakes in your organization, depending on the organization scale and the way how you have built your infrastructure. Obviously, platforms should provide streaming data capabilities to ingest the data, to process the data in streaming manner, and be able to provide streaming analytics on top of it. It will be beneficial if the platform will provide integration with the various ML platforms, both commercial or even those that can be built a part of the data platform, so that data scientists can leverage different tooling to develop ML models. So these are primary capabilities that we recommend a platform to offer to the consumers. And talking about one of the use cases that we have built to our customers, this is an IoT data platform that is ingesting data from various IoT devices in a streaming manner through AWS Kinesis. Then it lands this data in data lake for further analysis. And on top of this data, we are running ML models which identify anomalies in the data and report any issues with the sensors, any issues with the devices, a part of IoT network. And this issue identification is running close to real time. This architecture leverages such capabilities like ingesting streaming IoT data. Also, platform ingests data from legacy systems and also external API. And this is used for building models for identifying particular criteria in anomaly detection. And this actually provides, data ingestion from various sources helps us to build centric data lake with ability to query this data and provide this data to all consumers. When we are talking about gathering the data, one of the key points to gather the data is to provide this data to business users or to data science team. And in order to help data science team to create ML models on top of the data to identify trends in the data, to identify anomalies in the data, data science team needs proper ML tooling. And typically, we build platforms, ML platforms on top of data platforms, which leverage data platforms capabilities. Typical ML life cycle of model development looks like taking the data from the source or taking the data from data lake, data warehouse, prepare data extract, run data transformations which are required for this model. Then develop a model, validate it, tune whether it's needed, and then release it within the particular environment. And this life cycle should happen a part of the ML platform, which will provide all the end-to-end capabilities to run the model, to create data extracts, to train, to release it, everything. And further, we'll talk about how to build such kind of ML platforms and what are the benefits integrating it with data platform. So particularly ML platform will depend on various business data. It may be sales data, any kind of product data, information from sensors, and so on. And this data will be orchestrated a part of the data lake. On top of this data, ML platform will operate and build end-to-end pipeline for model development, will provide all particular features which are required, like model and feature store and tracking common model metadata. And this ML model will help to implement particular models like which will help to run safety stock optimization, workforce optimization, whatever business objectives are. Moving from a particular business capabilities of the model of the platform to its technical implementation, I would like to call out specifically that these ML platforms may be built in two ways. Either it will be a commercial product which is integrated with your data platform, or it may be a ML platform which is designed and implemented from scratch, like on my screen. Or it may be a case, then there are two complementary solutions. It may be a commercial product along with the data platform. Both are designed and implemented for particular business needs. Here, ML platform is leveraging particular capabilities of the data platform. It's depending on the data lake. Data lake provides access layer to the data, provides particular data quality checks on top of this data to ensure that the data in the data lake is at expected level. And on top of this data scientists may create features which will be used in experimentation, in any kind of model development, and these features may be even widely used across data science team. This ML platform is visualizing end-to-end development capabilities. Having a feature and ability to run experiments within the environment, then create a model, run model training, validation, and publish this model as a release, which can be used further in to be deployed to any environment. It may be a case of batch serving or real-time serving, where batch serving may be a model which is running on top of a part of the, for example, Apache Spark application, or it may be real-time serving, which is running on top of Kubernetes, which exposes a REST endpoint and provides scoring. It may be various cases, depending on the particular business use case. So this platform provides all these capabilities, including all types of serving and development pipeline, tracking model metadata, on top of model runtime, also a monitoring, which helps to monitor particular models and identify are there any errors during real-time serving, for example. This reference architecture uses, for example, Google Cloud, but they may be built for any other cloud, leveraging particular cloud capabilities, whether it's Azure or AWS, it will be more or less the same. This is it that I wanted to say in my topic of helping to transform modern manufacturing. Typically, we help them to build data platforms with particular capabilities that I have mentioned. And this is a sliced architecture that helps to build any other layers on top of it, whether it's ML capabilities, whether it's self-serving capabilities, reporting capabilities, or integration with third-party marketing platforms, which are used to run marketing campaigns. So that's it. And thank you for the attention. And I'm ready for your Q&A session.